Hello everyone, my name is Michelle Cole Bailey. Welcome to another lesson in mathematics. Today we'll be looking at place value. Now boys and girls, I know place value is not new to you. You have done it before in grade 2, you have done it also in grade 1, and here again we'll be looking at it in grade 3. Let's get into our objectives. By the end of the lesson, pupils will be able to interpret 4-digit numerals using thousands, hundreds, tens, and ones. Use given information to construct addition and subtraction problems. Use expanded notation with 2- and 3-digit numbers. Now that we have looked at our objectives, we are going to sing a little song. I'd like you to listen to it, and the second time around you can join with me. This song is done to the tune Bits of Paper. Here we go. Place value is easy to do, easy to do. It tells you the value of a number, of a number. Place value is easy to do, easy to do. It tells you the value of a number, of a number. Thousands, hundreds, tens and ones, tens and ones, tens and ones. Give the digits value of a number, of a number. Now boys and girls, we're going to do the song a second time. Here we go. Place value is easy to do, easy to do. It tells you the value of a number, of a number. Place value is easy to do, easy to do. It tells you the value of a number, of a number. Thousands, hundreds, tens and ones, tens and ones, tens and ones. Give the digits value of a number, of a number. Thank you for joining with me in the song another time. Now from the song, can you tell me what is place value? Let's read. Place value tells us what value each number has based on its place or position in any number. Let's look at our digits. For us, we have 10 digits. We use a base 10 system. If you notice on screen, you'll see 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All those will give us 10 digits. Our base 10 system helps us to go up in units of 10. If you look on screen, you'll see I have a place value chart. To the far right corner, you notice the word ones. As you go towards the left, you'll see tens, and then hundreds and thousands. As I said before, we have a base 10 system. So it takes 10 ones to make 1 10. It takes 10 tens to make 100. And it takes 10 100 to make 1,000. I'm sure you use money at school and on the road when you go shopping with your parents. And you know, boys and girls, that when you have 10 $1, that makes one $10. When you have 10 $10, that makes $100. And when you have 10 $100, that gives you $1,000. Very good. Here we have an example of Matthew in a problem situation. Matthew has 15 marbles. If he is to place these marbles in groups of tens and ones, how could he place the digits to show the correct value for each digit? Here we have 15 marbles. You can count them with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in all. Now we would like to show the value of how 15 marbles can be represented on the place value chart. So let's move to the board. Can you tell me how many tens and how many ones are there in the numeral 15? Let's see how I will represent this. Starting from the far right corner where we have our ones represented here and our tens here, we'll have 5 and 1. So in all here, it shows us that we have 5 ones and 1 group of 10. That would represent Matthew's 15 marbles. Here is another representation of the 15 marbles, showing tens and ones, 5 ones and 1 group of 10. Let's examine the number 2. Number 2 is asking us a question. It's saying something here. When you look at number 2, am I 2 or 20 or 200 or 2000? If I just knew my place, I would know my value. Now, boys and girls, where do you think we would put number 2 on the place value chart? It's 2 by itself. So it means that that would go exactly under the ones column. 2 ones. The number 2 would be 2 ones when represented on its own, without another number. Therefore, we would place it under the ones column on our place value chart. Now, in doing mathematics, boys and girls, there are a number of tools that we can use to make maths fun. Here, I'm illustrating for you some base 10 blocks. If you look on screen, you'll notice a very large block. Can you tell me how many units are in that block? If you guessed 1,000, then you are correct. The block illustrated in color green represents 100 units. That's a 100 block. The blue block beside it represents tens. So that's a block of 10 units. And the very small block beside it, that is 1 unit. Let's go from the far right now. We have the small block, which represents the units or the ones. The one next to it, the tens. The one next to that one, the hundreds. And the very large one represents the thousands. Here we have base 10 blocks showing 1,000, 100, 1 group of tens there, and 4 ones. If you notice, I'm asking you the question, what does the blocks represent? We have 1,000, 100, 110, and 4 ones. The number represented is 1,114. Let's look at these. Can you guess what the number is based on the blocks shown here? We have 2 sets of hundreds, 3 sets of tens, and 5 ones. What is the number? The number is 200, 3 tens, which is 30, and 5 ones. Hence, the total amount would be 235. Can you tell from the blocks here what number this is? There is 100, 110, and 4 ones. So our number would be 114. Here's another example. We have 2 sets of hundreds blocks here, 4 tens and 3 ones. So our number is 243. Now let's look at this example. There is 1,000 block, 200 blocks, 4 under our tens column, and 3 ones. So here represented we have 1,243. Can you identify the word name for 1,423? Let's look at some answers. Is it A, 1,433, 1,343, or is it C, 1,232, or D, 1,423? Let's go back and look at the number. Take a close look. Let's go back to our answers. What do you think the answer is? If you said D, then you are correct. As I said earlier on, there are a number of tools that we can use to solve mathematics problem. Another tool we could use is the abacus. What is the abacus? The abacus is an ancient calculating tool formerly used all around the world. It has been largely replaced by calculators because of the vast range of functions they can perform. But it is a fun tool to use in mathematics. Here is an example of the abacus. There are several examples of what the abacus looks like. You saw one earlier. Here in my hand, I have a model of the abacus. If you notice closely, right here you have H. What do you think the H represents? If you said hundreds, then you are correct. And next to the 100, we have our tens. That is what the T represents. And next to that, we have our ones. Now we can use this little tool, the abacus, to show different numbers. Can you use your abacus to illustrate the following numbers? 5, 42, 134, 2,350. Where would we put our 5 ones? We would put them at the ones section. Here we go. The next number is 42. In 42, we have 2 ones and 4 tens. So we'll show 2 ones on our one section of the abacus and 4 tens. 1, 2, 3, 4. This is 42. Now let's move on to 134. There are 4 ones, 3 tens, and 100. Let's put on our ones first. So we have 4 ones, that's 1, 2, 3, 4, and 3 tens. 1, 2, 3 tens, and 100. Here we have illustrated 134. Now with your teacher, I'm going to allow you to work out the final one, which says 2,350. Remember, on my Abacus, I had 3 different sections illustrated: 100, tens, and ones. But we can also move to the 1,000 position. So with your teacher, you will be working the final one on your own. Here are 2 more problems for you to work on. Matthew has 14 Skittles. His friend Jerome gave him 12 more. How many Skittles he has altogether? You can use your Abacus to solve that as well with your teacher. Here is another problem. Zarike's mother gave her $260 for her lunch money. On her way to school, she paid $50 for her taxi fare. How much money would she have left? I'm sure you have learned something new today. Now let's review our objectives to see if we have covered them throughout this lesson. Did we interpret 4-digit numerals using thousands, hundreds, tens, and ones? Yes, we did. Did we use given information to construct addition and subtraction problems? We did. Did we use expanded notation with 2- and 3-digit numbers? We did, boys and girls. I am Michelle Cole-Bailey. See you next time in our maths lesson. Have a good day.